We've got a little bit of housekeeping first. Just a reminder to everyone that there's a hackathon tomorrow. So that's in this room from about, well, I think technically 11, but maybe you have to get in here earlier. So that's for people to come along, as Barry had said, to talk about virtual router stuff, anything else you've seen. I think the UI ideas, I think Rohit would like people to talk about. I think on the mailing list, a few people have had other ideas of subjects they'd like to get people's feedback on and try and get consensus around. We've also got a community video project where we're asking people to do a sort of 10-minute interview, probably be video doing that to give background on why they use CloudStack, how they use CloudStack, for putting on the CloudStack YouTube channel. Just get people seeing the more details about that. So if you're interested in doing that, if you could find Andrea or Steve or Giles from ShapeBlue, or grab me either, and we'll make sure someone gets to speak to you about that. Okay, that's that. Okay, so the backup recovery frameworks I'm going to talk to you about. It's almost here. We had to kind of do a bit of a pause on it because one of the people we were working to wanted to pivot and do something else. But then we thought this is too good, too important to just leave on a shelf. So we went back to it and have carried on working on it. And so I'll give you more intro of where we are. I think by now you've probably all figured out who I am. As Vice President and Chair of the CloudStack project, also CTO for ShapeBlue, and I've just spent an awful lot of time doing CloudStacky things. I think probably it was around January 2012 that I got involved with CloudStack, so I'm probably among Rohit and only a few others that are still around so actively in the project from those early days of Citrix. So what I'm going to talk about is a bit of background to the backup and recovery framework, what it's about and what it's going to do, and show you kind of how that's all now going to fit together. So if I start off by kind of rewinding a bit to where this all came from. And it comes from a lot of talk, and people will have a lot of pain around snapshots. Be it public or private clouds, people use snapshots as basically a backup. But when we look at what I should also do is give kind of, for anyone who doesn't know, who is really new to this, what we're talking about when we have snapshots. So we've got two types. One is just a VM snapshot, the kind of thing that most people who are used to virtualization and hypervisors would think of when we use the term snapshot. That just kind of point in time image of the VM, and then it carries on from there, and if you want you can roll back to that point in time. But it's stored with and alongside your virtual machine that you've got. Then you have, or CloudStack also calls it a snapshot, is the volume snapshot. And we use part of the same idea in that we take this point in time snapshot, but then we copy that from the hypervisor to secondary storage. And then we delete the little snapshot we took on the host, so that now you have a copy at that point. And the reason the rewind to snapshots is because pretty much everyone uses snapshots as some form of backup. It's really what the only in CloudStack option you've got. The other ones would be installing agents as users into virtual machines and doing backups that way. But the only way really provided by CloudStack are these snapshots. But the thing is, there's some issues around doing that. And the first thing really is it's about consistency. They're not going to be consistent across volumes because, in fact, and a lot of times CloudStack can't take more than one volume snapshot of a VM at the same time. So if you have multiple disks, say one with logs on, if you go back to your like SQL server where you're recommended to have a disk for data, a disk for logs, a disk for the OS, you're going to take those snapshots one after another, and if they're large, there could be hours of difference between the OS at the logs and the data, and then when you try and put that back together to roll back, it's going to be a huge mess. And if you look closely at what's wrong with this picture, is you've got the baby's head over here and what looks like Tim Mackey's head over here. They just don't match up, and when you put them back together, if you end up with that, an unholy mess that's probably unsortable is going to happen. There's also the fact, this is a very sledgehammer approach to doing this backup. It is taking a snapshot of exactly how something is at 1 second. So if you've got databases, those logs aren't going to be quiesced. They're not going to be flushing databases and making sure everything is nice for you when you start up. It'll be possibly crash consistent within the scope of a volume, but that's still crashed and not in a nice state. And so you're going to have work on your hands trying to put back together whatever you had. The real pain for then the people operating the cloud is often it's slow. It's limited by the bandwidth you've got available to you. It's limited by the storage you have. If you don't have many secondary storage pools, everything has to get into there. And if you have a lot of virtual machines and everyone having their snapshots scheduled for, say, 11:30 at night, then suddenly there's a lot of data that's got to get onto that secondary storage all at the same time, creating massive bottlenecks. And also in vSphere, we have the case of the fact that the SSVM acts as a client. It's doing the compressing of the data into the OVA to be then stored on the secondary storage. That, compressing anything takes time. Compressing a terabyte disk to be then put onto secondary storage is going to take a lot of time and a lot of resource. And so you're going to get a lot of contention. You would almost need one of those SSVMs per snapshot job to try and get decent throughput. So there's a lot of problems there. And obviously, as I say, CloudStack locks out a lot of other actions while that snapshot's taking place. There are some workarounds that people have put in, things like asynchronous snapshots. But they have their own issues because you tell CloudStack, I want to take a snapshot of this, do it asynchronously, so you tell me, yes, I've done it as soon as the first snapshot's taken, and then asynchronously that gets stored to secondary storage. If you are wanting to create a template from that snapshot, you're now hanging around thinking, well, you've told me you've finished this snapshot, but I can't actually do it because you're telling me you're now backing up the snapshot. Well, I'm actually no better off. In fact, I'm slightly worse because now I'm not sure what's going on. I have to keep holding myself to find out that the backing up of that snapshot's finished. So you've kind of just, in some cases, just moved the problem somewhat. And then there's the restoration of a virtual machine that you have created a snapshot from, if that's what you're trying to do. You created this snapshot for the purposes of it being a backup. Well, that presupposes at some point you're going to want it back for some reason. You can't, under most circumstances, just say, I want that snapshot back as my VM. And most of the time you're going to have to create a VM from that a template from that snapshot, and then create a virtual machine from that template. And when you start adding up how many times you have to move data around to do that, it takes an awful lot of moving of data. Bearing in mind it was slow enough the first time when you only did it once. If you've got to move the data around 3 times, it's going to take at least 3 times as long. And even then, it's not the same VM because it'll have different MAC addresses on its NICs, because now it is a VM created from a template created from that disk. So way back, as you can see, a couple of years ago, this was annoying me enough that I actually created a wiki page and said, these are the things I think we should be trying to achieve, and rather than trying to make snapshots better, we should just kind of pivot and say, right, we need backups. We actually need backups that do what backups are supposed to do. And then created a list of the things I thought were required around that, what I thought we needed. And then we worked with a couple of vendors and actually cloud providers to find out what they thought of that, what they would like to see, how they would try and drive these things, and came up with the old document, which we then started work on. So I keep calling it, and the title keeps saying Backup Recovery Framework. And the reason for that is there are a lot of different vendors out there and they have different ways of doing things. So what we're trying to do here initially is abstract those things. Take all the things that you would expect your backup solution to do and you would ask it to do, extract that out, and then create effectively the APIs to do that. So I'll come on to what those APIs are. But then behind that, create the framework for plugins, which would then interpret those APIs into however any third-party backup solution is going to work. So you've got the APIs that are going to be completely consistent and abstracted from what the solution is in the background, and the drivers to plugins to actually do that on what have you. So, operations we're trying to do. Well, as I say, the challenge you've got is terminology tends to be very vendor specific. So what one vendor will call a backup is a job, what someone will call a chain, it will have different names. They've all got their own terminology and also different models of how they think backups are going to work, what it's going to look like, how you go about doing it. And some of the vendors' products are especially unfriendly to try and work with. They come from real old-fashioned enterprise type constructs and don't play nicely with certainly APIs, with the concepts of what we want, the multi-tenancy you need in clouds. Another concept and idea to look at is the idea of scheduled backups. Well, we've had that with snapshots. Ad hoc, we have those with snapshots as well, just as and when. But also SLA based backups, which is a whole kind of different concept that came in as a particular vendor, I think, that brought it in. I think it was Rubrik that went with this idea. Say the two don't really work together. They have a different construct and different idea, and it's best to keep them separate. But what is an SLA-based backup? Well, it's instead of saying I'm going to do a backup of my virtual machine at 11:30 every night, you'll turn it around and say, well, what I'm really saying is I don't want to lose more than 24 hours of data. That is your store point objective, 24 hours or less. And it might be 8 hours, it might be a week, it depends what the virtual machine is, depends what your use case is. So you create this policy or SLA or offering or whatever you want to call it, and you say, right, so I have a store point objective, how much data I can afford to lose, basically. How long I'm going to keep that before it's just expired or expunged or retired, and potentially a backup window that says, well, I have a lot of busy stuff going on in this particular time. I don't want the backup to be happening then. I don't want all the movement of data happening then, but any time between, well, let's say, honestly, most people are going to say, oh, okay, well, any time between 8 o'clock in the evening and probably 6 a.m. in the morning, I don't really care when that happens because nothing really happens in that window. And it has some specific advantages. The first one is for the operator themselves, because rather than having thousands of jobs all being started at exactly the same time, what you now have is the ability to now schedule when those happen yourself, or hopefully your software is going to do that for you. Your backup software is going to see, well, I've got this amount, the best fit to get as much done as possible is that one there, that one there. Maybe it's looking across your estate to say, well, this is going to that storage, that's going to that, so I can do those in parallel. So I could do each host one job at the time and then the next job. And so you're getting proper parallelism rather than a kind of, well, it's all over the place and actually I'm completely locked up on this one. The other advantage is a much simpler backup offering to customers, your end users, where instead you just say, you can have gold, silver or bronze, take your pick. We'll take care of everything else. You just pick what it was, and this is what it will cost you for that, this is what it will cost you for that, that's what it will cost you for that, and say, that is it, that's the way this works. And certainly I know some of the cloud providers would like to go that way. So you can't do your schedule, you've got, this is the option you've got, and now everyone knows where they stand. And I think lastly in the terminology stakes, for people who are kind of used to this, it's fairly well known, but basically as a VM has a life, you do your backups and you're creating restore points. And Veeam, it calls that a job, and you just keep rerunning the job to create the restore points. This is where we start getting into terminology. If we started calling things jobs in CloudStack, no one would know what we were talking about, particularly as other things don't call them that. So taking a backup, as it were, creates that store point or just runs the job. And then you have a chain, and you've got, obviously, think of that as the container for the store points. For instance, when I talk about the sort of vagaries of different providers, Veeam doesn't have the idea of deleting a particular restore point and then recreating a chain. If you're going to delete something, you either tell it, well, I only want to keep 2 restore points, at which point the next time the job will go, it will get rid of the rest, or you say, I just want to delete the whole chain, but you can't do something in the middle. That's just how Veeam works, and so that's why we kind of look at what terminology makes sense in general and then have to do mapping in between. And for delete that restore point, basically for Veeam, we'd have to return you can't do that. Actually, what's nice is if you look into some, say, the API discovery that Rohit's been talking about, if you have the Veeam plugin, we would have that, well, delete, restore point, delete a particular backup wouldn't be available, you just wouldn't see it in the UI. And if you tried it in the API, you just get told you can't. So, that's the way we'll have to work with that one. Other backup vendors will allow it, and so it will be there. So, that's why it's a framework. We're trying to separate the logical, these are the things you're going to do, from these are the things that the backup you've got can actually do. So, some practicalities. I said I've kind of almost got the slide at the end in the wrong place. This has been designed to work with Veeam. So we've done a Veeam plugin. We've also got a dummy plugin, so testing in the API can work. But a Veeam plugin, and that's the first of the vendors that will cover. I think there are a few other vendors that are interested, and I think basically we'll wait to see what this looks like before jumping in. Hopefully what will actually follow is cloud operators will say, oh, well, it works with Veeam, we want to use X, and then someone else will then develop the plugin that does the same for that, and then you'll have a whole suite of ways. We were talking to the guys at Storpool. Now they're actually front-end storage, a Ceph-like type storage idea, but they can copy data, hot off their storage into some other form of storage. Well, that's basically a backup, and talking to them about, well, they can create their own plugin that will leverage all this. And when you say do a backup, it's actually doing it entirely in their own storage backend, with not really a backup vendor involved at all. Well, that's the way this is designed to work. So, the first kind of thing we have to do here is you create in Veeam like template jobs. That's got to store stuff. Actually, I think I'll show what they store in a second. And what we do on the CloudStack side is link to that job. So on CloudStack, you may have actually on here given it a really long name that describes exactly what it is. On CloudStack, you could call it gold. And then it's linked to that job. Someone says, I want to use the gold policy, in this case, offering, is going to be linked to that job. And when you say, I want gold on this, it will work from there as the template. So what you're doing in this template is, for instance, specifying, right, so this is it's going to do it every 6 hours, some stuff about when it might retry. And here's the kind of schedule bit. So you might actually say, between these hours, you're not allowed to do it. Maybe there's a particular time when everyone's logging on. So every 6 hours, but not between the hours of 8 and 10. So between the 8 and 10, don't do backups because everyone's logging on. The system's going to be hit pretty hard. I don't want you doing anything on backend then, but the rest of the time, knock yourself out. And then anything else that you're going to do. Now, in terms of these, part of the job specifies where the data is going to be backed up to. And it supports a whole load of different things for Veeam. But obviously in each zone that's going to be different. So there'll be a different template for each zone so that you don't start trying to back up from your system here to S3 storage on the other side of the world, because then you've kind of lost all the advantages you're trying to get. So they're going to be specific to each zone most likely, unless you have a nice, cleverly, globally distributed S3 that makes it all easy. You're going to need one for each zone probably. And there's some other little features that are in here with guest processing for Veeam, being application aware or doing indexing the file system to ultimately allow you to pull individual files back. So actually, instead of saying I want this whole disk back, you say, well, I want that file that was in there in the backup I did 6 weeks ago. Because it's abstracted from CloudStack, this stuff CloudStack doesn't need to know about. All it knows is it's running that gold job, and maybe the gold job includes this, and the bronze job doesn't. But it doesn't matter to CloudStack. That's been separated out. In terms of the ad hoc and scheduled backups, that's a case of CloudStack just keep firing. The job gets created and sits there. CloudStack's just going to say, right, run that job. And obviously in the same way as it does for scheduled snapshots, when it hits that scheduled time for a snapshot, instead it's going to hit scheduled time for a backup and fire that job, and you get a nice timeline. The reason, I'll go back to here, the reason that you kind of have to keep ad hoc scheduled separate from the idea of a policy is if you imagine another copy of this timeline with the same VM, if you have another thing with restore points in different place, as soon as you restore back to, say, the one for your schedule to here, this doesn't make sense anymore because you're kind of midway between restore points, and how can it get back? The next backup it takes will go to here, and it's not a logical link, so that's why you have to keep them separate. I've said in this case, we'll have a list of VM backups, and Veeam thinks of these in terms of restore points of the VM image. So using the API, we'll basically be listing the restore points for any given VM. And lastly, in this bit restoration, which is obviously, again, why you do the backup in the first place. A vagary of Veeam restoring a VM is that its in-place restoration is not in place of the original. It's no, I've done that wrong way. So you don't write over the original VM when you do a restore using Veeam. It creates a new VM, which is of the from the backup, and then destroys the original one and gives the new one the same name as the old, which does mess around with a few bits, and CloudStack gets very upset about this VM has actually disappeared, and I do have a new one with a new UUID under the backend that it can't find. So then we have to ask CloudStack to go find it again and bring it back in and call it the same name. Fortunately, this segues nicely into the idea of discovering a VM and bringing it into CloudStack, because effectively a new VM has appeared that we didn't know was there before. So we had to write something to do that. We then, and it should be in, if we do something at Christmas, the next major release, a VM ingestion feature which will have general purpose use for discovering on VMware at the moment, but it's been written agnostically, discovering VMs that are in the infrastructure that CloudStack isn't managing and bringing them into CloudStack so that you can now manage it. So that was a kind of, we could see that was going to be 90% we're going to have to do for this feature, and we should roll it out as an individual feature as well. And already in the current implementation, we have restore a volume and attach it to a VM, so that if you've got a whole load of data you want to get back, you said, actually, I'm going to recreate my SQL server. I just want to get the data out of the old one that died. You can then get the backup mounted into your new VM and then just copy, which is the fastest way to get that data from one place to another. Just copy that data off, because the volume you've restored is just mounted in the new VM. So, the actual APIs we've got. So the configuration. So from the operational side, you're going to be able to list the backup providers, and they're going to be the plugins basically that's been added into CloudStack. You then will be able to go to those providers and list the offerings that they have in them. So they're basically those templates. Then you want to import those offerings, which is making the link between what CloudStack's going to call, let's say, Gold, and the Zone 1 super great backup that runs every 6 hours and gives you an indexed file system. And then we'll call it Gold in CloudStack. But there's something that needs to make that link, and that's how we'll do that. Then we obviously need to be able to list those offerings you've created in CloudStack and delete that mapping if you need to. So that's what the kind of back-end initial configuration would be from the operator side. The user will have the scheduled things that we have already as snapshots, but we'll be able to create, update, delete, and list your schedules you've got there. Then obviously the actual creation of a VM backup, the listing and deleting. Remembering we'll have to do more special things around deleting for V. So for instance, you won't be allowed to delete anything other than basically the first backup, which will delete the job. You can't delete an interim one because V doesn't do that. And that will be the job of the plugin to return that when it sees you're trying to do something it can't do. Then you have these offerings, these policies, whatever you want to call them, the SLA based ideas. You need to be able to assign a virtual machine to that and say, I want that to have the Gold offering. And also you want to be able to remove a VM from having that offering as well. And then finally, restoring a VM that's been backed up. So that's just bringing the whole thing back and either replacing a VM that you have still. But then these will be first-class citizens. So if you've deleted the virtual machine, but not deleted the backups, you can still restore from the backup. So until you delete that backup, that will stay regardless of whether you deleted the VM or not. Especially because it's a backup. You deleted the VM you didn't mean to, you want to still have the backup there. And then restoring a volume from backup. Currently, restores and connects to a VM and asks you which VM you want to mount it on. We'll probably add something where you can restore the volume and put it in secondary storage, where you can then move it around, copy it, mount it on something if you want, or just leave it there and delete the rest of the backups potentially. So what it's working with, we wrote it. So there's a dummy plugin that's just used for testing, but the plugin we've got was tested against VMware 6.5, and was written against the Veeam backup and replication. I think it was the Enterprise Plus version to be able to do all the things you want. And at the time it was 4.12. Obviously we have 4.13 coming, so we may have to make sure, test that there's no problem with that. These are the parts of Veeam that it requires: the Enterprise Backup Manager and the Backup and Replication Console, which are all part of Enterprise Plus, I think. We also had to install OpenSSH and PowerShell on the Veeam server, because there are some things you can't do over what there is of an API for Veeam. You actually have to PowerShell in and tell it to do things. As I say, some of the vendors are not especially cloud friendly when you've got to do that. And so finally, where is it? Well, there's a pull request there. Now, what we found is this is kind of like an alpha, and when we put it together and then looked at it and started working with it, we found a load of things go, that doesn't feel nice, that kind of feels a bit clunky, doesn't make sense for us to do that and do that. Some of the APIs were found a little too Veeam centric. So it's there and it physically works. You can back up VMs and get them back using it, but we still want to do some more work around that at the moment. So I think our current plan, we're going to separate those UI and API bits of the PR and work largely on the API bit to get that into the next release. So we'll refactor those API parts from the lessons we've kind of learned by having a working, it's a bit more than a POC, it actually is doing everything, but we'll take the lessons we learned there and apply those. We've got to finish the scheduling of backups, so you can do ad hoc ones, you can do policy-based ones, we've got to finish the scheduling ones. And at some point we figure people might want to change, that they had a gold backup and realise, now I want a bronze backup instead, and how we handle that transition from one type of job to another, effectively a different job. And the completion of the UI, we'll kind of see if we race through this. Maybe we'll get the UI stuff in the new version, next version, maybe not. But our target is to make sure the API bit is merged in for the next version, so it's all there. A lot of cloud vendors have their own portals, so they wouldn't be worried about the UI piece so much anyway. But having the this kind of rough UI as a separate PR, people can then still merge, do their own merging of that and have a package that has it in and then play with that as something that's not finished. But we didn't want a partly finished UI for backup recovery going into a proper release. It just, you can't do that. Whistle through that. Are there any questions I can answer around that? that was way too keen. Yes, Marcus.
I've got two questions. One is, I like the API and the abstraction and the pluggable design. Did you prove it against any sort of like client-based or like file-based? So, I'm imagining potentially, VMs, for example, could have agents, and you could have some sort of backup service, and you could have a plugin that you can use to trigger, an agent-based backup. So maybe you only care about certain files and whatever. Did you kind of go through the exercise of figuring out would it work with a file-based?
Yeah, when you thought about those abstractions, there's nothing to stop it doing anything. So the API will be backup VM. What that does after that is down to the plugin. So it could do absolutely anything, yeah. It could be really horrible SSH into the VM that you gave and pull stuff out. You could have the most noddy, horrible thing, and you can use the expression bastardized. I'm not sure I'm allowed to say that. You could mock up almost anything from behind that. That's the idea.
Yeah, and then restore side, I'm assuming the plugin is kind of free to do what it wants on the restore, right?
Yeah.
Like it could create a new virtual machine in CloudStack and then assign it to that, or it could,
Yeah.
I was curious with the Veeam specific example you gave. You mentioned basically it creates a new VM, VMware. Why can't the plugin implementation see that and then rename it to what CloudStack expects it to be, or just detect it? Because you mentioned that you have some sort of discovery, general purpose discovery, to kind of solve the problem there. I was wondering, why can't the restore implementation do that?
It could, but it was effectively it is. It's just leveraging a bigger thing. It actually, I think, as I recall, the main thing it's doing is go finding the disk and saying, actually, this disk has appeared. It's in this storage pool, and it's this size, and basically creates those entries in the volumes table, and then links that to the VM and takes out the old one. So it's just remapping where the volume is, effectively. But it's got to do that. It's got to create the volume in CloudStack. And that's a concept that's never been there before, of something exists outside of CloudStack and it's now in CloudStack, as opposed to CloudStack creating it itself. And then that's being abstracted out. Abhishek's been working on it. I think the PR's pretty much ready to go, where it now will do that for the entire VM. So here's a VM. It has this many NICs, this type of disk controller, these many disks, and then populates the CloudStack database to match what was there, and suddenly you can start it, stop it, do whatever.
You say that's only for VMware?
It's been tested against VMware because it has to go read from vCenter what things are. The move to then write it for something else is now only the ability to go read KVMs, version list, and get that domain XML and populate that. Yeah, but the actual putting it into CloudStack's done. It's now then just going reading those things. That's all that's left to do for KVM Zen. It's relatively small amount of work left to do that. We'll get one in, and then I assume we'll see a lot of appetite for KVM and others. I mean, the cool bit there is where you start talking about shutting the thing down and then converting the disk and then bringing it in. And then you've got all sorts of things. Another interesting thing with Veeam is it has its Cloud Connect. And basically what there you do is you take a whole load of people have there for onboarding VMs. If they happen to be using Veeam, they can upload their backups to a central place that the CloudStack would be able to see, or the CloudStack Veeam would see. And then you can, by doing that, you've got you only need to do your final diff, your final incremental update, shut that one off, and basically restore it into CloudStack. And now you're onboarding from anywhere, and it doesn't have to be geographically in the same place, because you're then doing these tiny little incrementals.
That's a good answer to my question, because basically you're saying if the VM doesn't exist even in CloudStack, you can still do a restore and pop a new VM out of it.
Yeah, wherever it came from, and we'll just read the data of what it was. So that whole thing is, it kind of snowballs out. You go, wow, we can do so much with this now. Anyone else? Yes.
Yes. I thought about the SLA offering.
Yeah.
Have you thought about involving other time-consuming jobs, such as virus scanning, patch management, or other things, so you could split the time in a central way?
Yeah, I mean, what we're doing there, you can use the same construct for anything. We've passed all the hard work and the thinking off. We've offloaded that off CloudStack. CloudStack is linking this offering to something else, which then will run. And it's it's linking obviously the offering to the virtual machine and something else. So there's no way no problem with, I guess, if you've got an antivirus that has, I guess it needs to already have the agent on a VM. But yes, you could then attach that VM to the policy, and then and then it's up to the backend, the plugin to tell the antivirus now run here, but we've offloaded that. So the clever bit of deciding when would have to be in the third-party thing.
It would be nice, for instance, for patch management to know that this VM is backed up now.
Yeah.
You could do the worst.
Yeah. Yeah.
Didn't you put the word backup in that API?
Which one? In this, yeah. But it's the construct of policies rather than solid specific schedules can be applied to anything. All we've done is link the virtual machine to this policy, and then the plugins told the back end, right, this VM needs to have that policy applied to it, whatever it is. And that policy might be on the, you might be telling antivirus system, right, it now has this antivirus that I want you to be running, or whatever the thing you want to run is, you've linked that VM to it. So the construct, the idea can be applied. Anyone else? Cool. Well, thank you very much, everyone. Oh, and obviously I should say, as always, we're hiring.